Greetings, I'm Bruce and I'd like to talk about Oilfield Innovations' self-assessment of our new plug and abandonment technology. Oilfield Innovations' primary new technologies address challenges in plug and abandonment, or P&A, challenges in well and normally unmanned installation design, and challenges in drilling. Today we will assess new technologies associated with our ring fence of plug and abandonment patents and our patented downhole diamond wire cutter. A copy of this presentation can be downloaded from our website for your convenience. Assessing any new technology requires looking at the technical problems being solved, the market size of the problem being solved, the value of the services needed, and the potential long-term financial value of developing the solution. So that you can understand, we will provide a brief discussion of the technology. Detailed technical explanation of Oilfield Innovations' universally compliant rigless plug and abandonment technology can be found and or downloaded from our website. Generally speaking, as shown here, our method requires 4 to 6 people and wireline equipment. This is a picture of a slickline lubricator being disconnected from the well pressure control equipment to unload a tool that has been run on wire. 5 of Oilfield Innovations' patented solutions comprise rigorously creating or using a logging and cementing space, which will be explained better in the following slides. Generally speaking, these new technologies are applicable to all offshore platform and subsea plug and abandonment. The technology may also be applicable to onshore P&A requiring snubbing, casing milling, long-term plug monitoring with regard to groundwater formations, and the conversion of P&A wells into test wells for R&D purposes. Our diamond wire filament cutter is also applicable to pipe recovery operations and downhole severance markets. Customers for Oilfield Innovations technologies are P&A budget holders, excluding those who benefit from the use of drilling rigs. Governments seeking to reduce tax deductions for P&A, as well as universities or R&D centers wishing to develop new technology, are also very interested in our patents. In a nutshell, all of oil and gas wells are 80 to 90% liquid space within the internal diameter of the casing. Vertically cutting and or weakening one joint of tubing allows another joint of tubing to be pushed alongside it to achieve at least a 50% compaction rate. In other words, 200 feet of tubing can be compacted into 100 feet of space to leave 100 feet of unobstructed space for in situ cement logging and abandonment cementing. One joint of tubing can be pushed alongside another split piece of tubing using an inflatable packer. The remaining uncut tubing can facilitate plug and abandonment cementing. In the short term, field-proven oilfield equipment can be used, and in the longer term, specialized, more efficient equipment can be developed. Humanity has reinvented uses for the wheel throughout history. We propose using field-proven cutting wheel technology deployed on a skate and hoisted up and down to vertically split the tubing. The tool body can also use a cutting wheel to reduce the friction and partially cut the tubing to create a hinge-like effect that minimizes the force necessary to push one joint of tubing alongside a split piece of tubing. Such a tool can also be stacked and aligned to place numerous cutting wheels along a single path to minimize the cutting time. Alternatively, the same tool can be stacked and phased to shred the tubing in many different tracks when lifted up and down. Vertical cutting using proven cutting wheels can be combined with cross-cutting using a diamond wire filament for in situ casing cement repair and or rigless casing section milling. Vertically shredding and then cross-cutting turns tubulars and other equipment into confetti that falls down whole. Cross-cutting the tubulars is not necessarily confined to rigless P&A and may be used in rig-based operations to save rig time. Oilfield Innovations' patented diamond wire filament cutter, unlike conventional cutters, can cut through tubing, clamps, control lines, packers, casing, and other equipment deep within an oil and gas well to create space for logging and cementing during P&A, or, alternatively, rig-based retrieval of equipment. Oilfield Innovations have also patented technology for logging and cementing that leaves the tubing in place. Driving spikes through the tubing into the casing both centralizes the tubing for cementing purposes and can be used to transmit and receive cement bond logging signals. Logging transmitters and receivers can be permanently embedded in cement, with logging signals transmitted through either wire or the casing to surface, for long-term monitoring of the cement plug. This can prove that an effective cement plug was placed and remove all legal liabilities associated with P&A. The proliferation of unconventional onshore wells and fracking technologies have increased oil and gas company legal liabilities associated with groundwater disputes. But Oilfield Innovations has a solution. Customers generally do not like test well data because test wells are shallow and they do not represent the temperature or pressures where tooling will be used. Oilfield Innovations have patented the market of converting P&A wells into R&D wells, used to develop new technology to solve this problem. In addition to providing yet another ring fence around Oilfield Innovations' P&A patents, this P&A and R&D patent protects a service company's investment when collaborating with customers, universities, and other companies through a legal monopoly that provides a safe R&D workspace that has similar properties to the wells of final use. Testing in a realistic environment has significant value as it can lower the barriers to entering the market with new technology. In summary, Oilfield Innovations patents provide a legal monopoly for creation of a cementing and logging space within casing using tubing compaction. Step 1 of the process cuts and weakens tubing along its vertical axis. Step 2 severs the tubing and places a liquid soap or cleaning fluid in the well. Step 3 severs the tubing a second time to create a tubing spear that can be pushed alongside tubing below it, which is followed by running an inflatable piston. Step 4 inflates the piston and applies pressure to compact the tubing side by side to create a space. During compaction, the tubing is lubricated by soap or cleaning fluid to scrape and clean the internal surface of the casing. Step 5 uses the space created by compaction for conventional in situ cement bond logging, which mitigates the legal liability associated with plug and abandonment by proving in situ cement still provides a seal. Finally, Step 6 places a cement plug that is supported by the piston above the compacted tubing, which also provides a seal that prevents gas migration into the cement while it is setting. If you aren't familiar with such processes, it can sound complicated, but it's much simpler than drilling rig plug and abandonment, with a lower cost and significantly higher profit margin. Thanks to operators like ConocoPhillips, Centrica, Inquest, and the Oil and Gas Technology Center with matching government funding, Oilfield Innovations have simulated the compaction process for North Sea-sized tubulars, as shown above. This picture shows a 5.5-inch tubing joint speared into a split 5.5-inch tubing joint, whereby the side-by-side compaction was pumped out of the 9 5/8-inch casing, within which it was compacted, so as to physically see the compaction. As you can see, the 50% compaction rate was achieved with the coupling compacted near to the pin end of the tubing. Also, as shown on the left, we repeated the simulation numerous times with similar results to prove the concept. Oilfield Innovations also has projects with the Oil and Gas Innovation Center and the University of Glasgow, who will determine the mathematical relationships of tubing compaction. As described in this video, Oilfield Innovations has a number of patented solutions to P&A that can benefit operators and service companies. Please feel free to email us with any queries you may have. To keep the size of the videos manageable, that concludes part 1 describing the problems being solved. Please watch our second video, which describes the market size for Oilfield Innovations patents, part 3, which describes the valued services for our patents, and Part 4, estimating the long-term financial value of the legal monopoly provided by our patents. Thank you for listening and watching our video, and please feel free to email any questions you may have regarding our new technologies. Thanks again, and goodbye.